Alright, so we're starting our second section of chapter 10 and we're covering solving right triangles, and we're going to use trigonometric ratios to find angle measures in right triangles and to solve real world problems. So for example 1, use the given trigonometric ratios to determine which angle of the triangle is angle A. So for our first one we have sine of angle A is 8 over 17. Okay, so we have to figure out sine, remember, is opposite over hypotenuse, so which one of these two sides, when put over 30.6, will give us 8 over 17? Okay, now 8 over 17 is the same as 0.47, reduced, or changed to a decimal, let me put it that way. So we check first with 27 over 30.6, we get 0.88. We check with 14.4, put that over 30.6, we get 0.47, and the 14.4 is opposite of angle 2, so angle A is describing angle 2 in this situation. Alright, so for B, again, we're just using the angle A, so the tangent of our angle is 1.875. So we've got to figure out, remember, tangent is the opposite side over the adjacent side, and then if you look, our two sides again are 14.4 and 2.7. So since this is greater than 1, let's check first 27 divided by 14.4, which is right here. It's 1.875. That 27 is opposite of angle 1, so the tangent of angle 1 is 1.875. Alright, now your inverse trigonometric functions. You remember in the last section we were finding the ratios. In this section what we're going to do is we're going to take the ratios and then find the angles with them. Okay, so you have this, so make sure you pause this, but basically I won't go through all three. What this top one is saying, if the sine of angle A equals x, then the inverse sine of x equals angle A. And it's the same thing for cosine and tangent. Okay, now how you do this in your calculator, remember, press the second button on yours and then find the tangent, cosine, and sine buttons, and you hit that, type those numbers in, and that's how you do the inverse of these. So inverse tangent of 0.75, you get 35.37. Remember, you round that to the nearest whole. That's how you get 35. Inverse cosine of 0.05, we get 87.13, round that to 87. Inverse sine of 0.67, we get 42.06, we round that to 42. Alright, right here, find the unknown measures, round lengths to the nearest hundredth, and angle measures to the nearest degree. Alright, so we look, they give us this length, which is 14, we have the 90, and we have this angle measure, which is 58. So remember, these two angles, D and F, will add up to 90. Excuse me. So 90 minus 58, that gives us 32. Okay? Now, there's different ways you can solve this, but we can find EF like they did here first. Okay? We know that the tangent of 32 will be the opposite side over the adjacent. So we can do x over 14 like they did here, except they put EF instead. And when you multiply, you'll get EF equals 14 times the tangent of 32. EF rounded is 8.75. And then right here to find our hypotenuse, we used the Pythagorean theorem and plugged them in. When you work that out and take the square root of 14 and 8.75, square them, add them together, and then take the square root rounded, you'll get 16.51. So I know with these it's a little tricky because they don't show every single step, so make sure if you're stuck on any of these to write down any questions that we can cover for tomorrow. Alright, so right here, the coordinates of the vertices of triangle RST are R is at negative 3, 5, S is at 4, 5, and T is at 4, negative 2. Find the side lengths to the nearest hundredth and the angle measures to the nearest degree. Alright, so here's the graph. Alright, to graph R, we would move 3 left, 5 up. To graph S, we would move 4 right, 5 up. And to graph T, we'd go 4 right, 2 down. Now if you look, we caught a nice break here because from R to S you move 7 places, and from S to T you move 7 places. So you got the length here is 7, and the length here will also be 7, which they have here. Okay, now there's different ways you can do this. I solved this as the Pythagorean theorem, but they did the distance formula to find RT. Either way is fine. You would get the same answer as the square root of 49 plus 49, all under the square root, which is 7 square root of 2. I don't mind if you leave it like that, but they rounded it to 9.90. And remember, this is a special right triangle. Since these two sides are the same, this would be our right angle at angle S. And angle R and angle T, since they're opposite of the congruent sides, would be 45. And this is what our last slide covers. You can also say, okay, angle S is 90. You can do the inverse tangent of 7 over 7, which gives us 45 degrees, because remember, we covered it in class, but the tangent of 1 is always 45 degrees, so the inverse tangent of 1, let me rephrase that. The tangent of 45 is always 1, and the inverse tangent of 1 is 45. Pardon me for that one. And then angle R you can find by 90 minus 45, and that's 45 degrees. So that's a different way you can solve that. All right, guys, that's it for these two sections for the week. I hope y'all have a great day.